only talked about conic sections, so circles, parabolas, ellipses, hyperbolas, with the center at 0, 0. And these are all the equations that we learned up until now. The circle one and parabola, ellipse, hyperbola, of course, for parabola, ellipse, and hyperbola, some of them open left and right, some of them open up and down. So it has a horizontal axis or a vertical axis. So go ahead and write those down now before we get to the new top secret information below. No, really, stop the video. Go ahead and write those down. I'll wait for you. So now we're going to talk about what happens when these things don't have their center at 0, 0, when they're translated left to right or up or down. So notice how all of these equations are exactly the same as the ones above. The ones below are just shifted by h and k, because h and k will be the new vertex of the parabola or the center of the other conics. So all the equations are exactly the same, they just have h and k. And notice how for every single one, it's minus h and minus k. That tells you that it will always be opposite. So, if it says x minus 2 and y minus 3, it's moved to the right 2 and up 3. Because h is the horizontal, so left to right, and it's opposite. They both are this time. And k is the vertical shift. So now that you have those equations in front of you, it should be a little bit easier to tell which type we're currently looking at. Now, unfortunately, instead of making like a 30-minute video where I go over each type of equation, I'm just going to go over one, and you're going to have to, translate that information to the other types. So this one says graph this equation. Well, looking at it, I already know that this is an equation for a hyperbola, because it's the y squared minus x squared. Now, from the chart, I know that this is a vertical one, because the y squared is the positive term, the x squared is the negative term, so it's going to open up or down. I can already tell what a squared is going to be, so a squared is 4, meaning a is 2. I can tell b squared, and b is 3. I can tell c squared, based on the information from the last section, a squared plus b squared. So we have 4 plus 9, 13, and c equals the square root of 13. Now, using all that information, in the previous section, I would have been able to make my graph really easily. I would have just plotted, it's a vertical one, so 0, 2, 0, negative 2. I would have just put some things here. And I would have put the foci, 0, square root of 13. And 0, negative square root of 13. And I would have put this over here as well. And plotted my graph. This graph, however, is shifted by h and k. So h is going to be here, and k is going to be here. If you ever get confused, just remember, h is a left and right shift. It's associated with the x term because the x-axis is left and right. It goes left and right. The k is associated with the y term because the k goes up and down. So what it's telling us is this graph is shifted to the left 1 and up 3. So the new center for the graph is right here. Then we can just plug in our vertex, our vertices at 2 and negative 2, our new foci at square root of 13, negative square root of 13, and our new b, which is 3 to the right and 3 to the left. Drawing this graph will look something like this. With this box being in the middle, because that's what we know hyperbolas look like. It has these asymptotes that run through. So our new graph, it's exactly like what the graph would be in a simple form, it's just shifted to this new position. The second type of problem is obviously backwards, going from the points to the equation. So it says the vertex of this parabola is at -2, 3, and the focus is at -4, 3. So what this tells us is it's a parabola that opens something like this to the left, and we need to tell the equation for that. So this is a parabola that opens left or right. The equation is in the form y squared equals 4px, because this is a horizontal one, opens left or right. Now the only difference is, this one, the vertex is not at 0, 0, so we're going to change it to the new equation, y minus k squared equals 4p x minus h. We can definitely plug in h and k. Remember, h and k make the vertex where it is. It used to be at the center, but it moved it up here, so h and k are really easy to figure out. So it's y minus 3 squared, because we want it to move up 3, equals 4p x plus 2, because we want it to move to the left 2. The hardest part might be trying to figure out what p is, but we're basically going to look at the vertex and this focus and say the distance between those two is p. So to go from the vertex to the focus is -2. So p has to be -2. So we can rewrite the equation as y minus 3 squared equals -8 times x plus 2, because the only way that the focus could be 2 to the left is if p was -2. So this is the standard form of the equation. I'm going to do one more example about an ellipse this time, for those of you who would like to actually watch more. If you feel confident that you can use these equations, then you probably don't need to watch the rest of this, but this stuff is pretty tricky. So I'm going to show one more example, this time with an ellipse. So this one says, write the equation of the ellipse with foci at 1, 2. I'm actually just going to graph this stuff out, it just makes it easier. And 7, 2, 7. And co-vertices at 4, 0, and 4, 4. So we know that this is a horizontal ellipse. It's going to be somewhat in this shape. We just don't know what the vertices will be yet. However, we know that the new center is going to be directly in the center of the ellipse, right there. So the new center is 4, 2. Now, because this is a horizontal ellipse, we can use the equation x squared over a squared equals plus y squared over b squared equals 1. And we can start plugging in information. Of course, because this one has been translated, the actual form we're going to use is x minus h squared plus y minus k squared equals b. And I know to put h and k with x and y because h is a left and right shift, it goes with x, k is an up and down shift, it goes with y. Makes a lot of sense. Now, we're almost ready to solve this. We know what the new center is. We know what h and k are. We know it's 4, 2. We just need to find out what a is. And to be fair, we don't actually know what b is yet either. Now, to find what b is, it's really easy, because the distance from the co-vertex to the center is 2. So b squared is going to be 4. And for an ellipse, the equation is c squared equals a squared minus b squared. C squared, we know what that is. It's the distance from here to here, squared. Because c is the distance from the center to the focus. C squared is going to be how we find what we plug in this equation. So that distance was 3. So that's 3 squared is 9. Equals a squared is what we're looking for. Minus b squared, which is 2 squared, which is 4. 13 equals a squared. A is equal to the square root of 13. That means we're ready to write the equation. So we have x minus h x minus 4, because we want to shift it 4 to the right, squared over a squared, 13, plus y minus k. We want to shift it 2 up, so y minus 2, over b squared, which is 4, equals 1. And that's going to be our answer for the equation.